Hello everyone, this is Peng from Parametric Design Studio. This video is a quick walkthrough on how to build a pedestrian simulation model in PedSim Pro, starting from scratch. PedSim Pro has a pretty similar modeling logic to PedSim. If you used PedSim before, you will notice that all the targets on the map have been unified into stops, and there is a person profile component that holds a collection of person parameters not related to wayfinding. Don't worry if you haven't used PedSim, because PedSim Pro's logic is actually more clear and robust, allowing a wider range of applications. So let's get started. First, let's make sure the model units is set to meters. And we can open Grasshopper. And we can start by placing an engine component onto the canvas and see what it needs as inputs. It needs a reset as a Boolean value. It needs person templates, obstacles, transparent obstacles, and population, and stops, and generation time. So let's provide all of these. Starting from the easiest, we can use a button for the reset. We can use the integer value for the population. Another integer value for the generation time with a unit in frames. We can draw a few rectangles representing buildings. And we'll have 4 buildings. They form a plaza in the middle. And we can have a polygon representing a fountain. In Grasshopper, we can use a curve parameter to reference the obstacles in 2 groups. One group is the opaque obstacles. Another group is the transparent obstacles. In the current PedSim Pro, both obstacles are required. If you don't have transparent obstacles, you should draw something as a placeholder outside of the simulation scope. Next, let's provide the stops for the simulation. There are 2 types of stops. They are stand and room. Let's use stands for our starting point and destination point. A stand has many inputs. Points as a list, names as a list, programs, and for the rest we can use default values. Let's draw 2 points and reference them one by one. We will create 2 stops. For the program, let's use a program interest component. It has default inputs for its name and color, so we don't need to provide anything at this point. The rest of the input parameters in the stand have default values. However, the visiting time of the stand is set to 10 seconds by default. Let's change that. Let's set it to 0 because we want people to exit the map immediately. Let's copy and create another stand. Now we have 2 stops, which is the minimum required to run the simulation. The final input for the engine is the person template. Let's use the person template component. It has a person profile, a list of stops, a list of interest and needs, optional person template ID, and probability and time limit, and color for visualization. Let's make a person profile first. In the person profile component, we only need to provide the first input parameter, which is the person's vision. Let's use the panorama vision, which allows the person to see 360 degrees. Now the person profile is ready. The second input for the person template is a series of stops. We can use the same list of stops, the first being the starting point and the second being the destination. Next, we need to provide interests. The interest refers to the same type of data as the program. So we can use another program component and we can set its name to none as a placeholder because those people don't have an interest yet. Once we connect the person template to the engine, it will generate vertices and edges. We call it a root graph. At this point, the engine is already running, but it only runs once. We need to use a timer to trigger multiple calculations in a periodic way. Now the engine is fully working. The easiest way to see the simulation is by using a draw person component. You can notice the person only starts from S1 and going to S2. We can easily change that by right-clicking the person template and change it to both directions. Now people are coming out from both S1 and S2. They will meet in the middle of the map. There are a few options on the Draw Person component. Let's display the person template's number. We will use that later. The people will avoid each other intelligently and avoid the obstacles on the map as well. Now we have a running simulation in PedSim Pro. This is the bare minimum. Let's add some more elements. Let's add some public seating around the fountain. This time we model it as a place of interest rather than a planned stop. We will use a stand, not a room, since the seating is outdoors. Because the seats are near each other, we can model them as one stand with multiple access points. Draw 8 points around the fountain. Make sure they are outside the obstacle. Back to Grasshopper. Let's modify people's current interest to seating. Duplicate the stand and give it this new program. Let's change its visiting time to 5 seconds for demonstration purpose. Change its access radius to 0.2 meters. Capacity is 8 because there are 8 points. We can use the same color for the program and the stop in this case. Once we reference the points, we will see a new tag in the center with the name and the program of the stop. We recognize it is a stand by the angle brackets. If it is a room, they will be round brackets. Now we need to connect the new stop to the engine. We don't connect it to the person template because it is not a planned stop. Let's reset the engine and run it. What should we expect? We can show people's current interest from the menu in the Draw Person component. There is still only one person template, so all people share the new interest. Once they see the seating area, they will all go there. Each access point can only accept one person. If one seat is taken, a person will go to another seat. If all seats are taken, the person will likely wait at one seat. Once people are rested, they will continue towards their next planned stop. In PedSim Pro, we can create multiple planned stops. Let's add some stops around the plaza. This time, let's use rooms. Let's make the first room a museum. Give it a different color. We also need to create a new program. In fact, let's call the program museum and call the stop M1. Connect the new stop to the engine. Should we connect it to the person template? Yes. And make sure we insert it in the middle of the list. Look at the person template's preview. Straight lines connect all planned stops in sequence. The dots on the lines represent the person's interests. Let's check the room's other parameters. Increase its capacity to 20. It's a tiny museum. Reset the engine. What's changed this time? All people still go to the seating area. After having a rest, they will go to the museum. After visiting the museum, they continue towards their final stop. Some of you may ask why people first go to seating, not to the museum. In fact, the other case can also happen. If all the seats are taken and the person decides it takes too long to wait, the person may first go to the museum. In reality, not all people are interested in sitting. Let's create a second person template. We use the placeholder non-interest again. Before connecting both templates to the engine, we should give them proper numbers as IDs. Remember, template 1 have no interests. Template 2 are interested in seeding. Finally, let's create another planned stop, this time a ticket house. Let's give it another color. All stops go to the engine. Check its parameters. Insert to the list of stops going to the person templates before the museum. Notice that one of the person templates arrow points the wrong way. Let's limit it to original direction. And reset. Now we have a group of tourists here. If you follow along, you can see clearly what they are doing and understand everything. A simple model like this can be created in a couple of hours. It can be a good foundation for a full pedestrian analysis for your design or research. If you like this video, please like and subscribe. Please go download PedSim Pro and try for yourself if you haven't already. Happy simulating!